SC. Can I talk to SC for a second?
Well, we can't just shut these guys down. Let's ask them politely first.
Shut it the fuck down. Go ahead, SC and Blue, go.
Yeah, go
No,
for it.
we're not going to shut you down, bro. Come on.
No, I'm going to
Okay.
bed. I'm pooped. I'm going to bed. So.
All right, later, Pazza. Go ahead, Blue. It's all yours.
Take it easy, fellas. Have fun.
All right. Good night, man.
Sorry, I thought I did ask politely.
You did.
Go ahead,
I just wanted to make sure.
Go ahead. It's all you, Bull. Go ahead. Do it up.
So you wanted to say something about the Ligo, SC?
Yeah, that picture there. Let me put it up.
I got it up on my screen.
You got it? Post it in live chat.
You want me to post it?
If you don't mind.
Okay, hang on. That one, right?
You don't even call Ligo.
Yeah, that's the one. Yeah.
If you can't have a vertical plane, you can't have a horizontal plane. What do y'all call them arms? What are they sitting on? How do you define them?
Can I get to SC's question?
Yeah. I just
let SC and Blue go through this Ligo thing.
What did you want to know, SC?
Yeah, like I was wondering. You got a 3 foot drop from one arm to the other, right? Or first of all, okay. Question number one: is Ligo on a plane?
It's two perfectly straight arms that lie in a plane. Yes.
Okay. So please explain the diagram. Because what I see here, I see like a 1 foot drop that way.
This is Ligo Livingston.
Baby cakes.
That's the one we're looking at. That upper arm up there. Well, let's see. That would be the southeast. Which one is which? That would be the southwest arm, I guess. Yeah. So the southwest.
The one at the
arm,
right angle.
Right.
Okay.
The southwest arm up there at the top, running left to right. Okay. Has end elevations of 64.12 feet and 64.09 feet. So the two end elevations of that arm are within 0.03 feet of each other. Okay. So if you just go on that basis, you would say that thing is virtually level. That's what you would call level because the two end elevations are the same, essentially. But the center elevation is not. The center elevation is 63 feet.
This is where I was getting at. Yeah. How is that possible?
Well, because the Earth is curved. That's why. Because that's what has to happen. The arm, if it was tangent, it isn't though. Now let me make sure we understand something. That's not the tangent point. But let's say for a second that center point of that arm is tangent to a sphere with a radius of 3959 miles. Okay. Then you're about 1.2 miles or so, 1.25 miles either side of center. And the drop over that distance is about 1 foot. Exactly what you see.
Well, hold on. Don't you have either end rising up from the tangent?
They're not rising up from the tangent, the elevation. The elevation of the arm increases, away from the tangent point. Yes.
On a plane?
That's a straight line.
Straight line on a plane and the center point is lower, and the two ends are higher.
Yeah. Imagine a ruler sitting on top of a ball, SE. The elevation, if you go out to the end of the ruler, down to the ball, that's the so-called drop.
Could be a tangent.
You've got to make that up.
Yeah, but hold on there, Blue. Your ruler is bent upwards on either end.
No,
It's
it's
no
not.
longer.
No, it's not. It's not been upwards, SE. It's perfectly
Well,
straight.
clearly there's a lower point in the middle and a higher on either end.
That's what happens with a spherical surface. You've got a perfectly straight line laying on top of a curved surface.
So that would make a straight line on a curved surface bend upwards on either end.
It's not bending, it's perfectly straight.
But clearly it's not. It's a foot. What is it? A foot lower
You're
in the
talking
middle.
about that's elevation now.
So you have a lower elevation in the center.
Yeah. The elevation in the center is lower than the elevation at the ends.
Hey, Blue Marble, you want to debate Troubling Tribune on the live stream, open panel? Any Globers or any Flat Earthers? He's going to have an open panel.
We're
So
doing it
anybody-
right here. We're doing it right
anybody-
here. Yeah, anybody can debate anyone right here. Let's do it.
Yeah, I know that, Jeremy.
SCs, you can go next. You can go next. SC's right in the middle of this thing now.
How do we even join Troubling Tribunes when we're not here? How do we join?
I just posted a link. But yeah, I'm not trying to steal your people, Jeremy. I'm just trying to see if anybody wants to do a live stream.
Oh, I thought you were trying to debate right here.
I will. I'll hang out. But I prefaced my statement. I was real specific about it. But, if you missed it, that's cool.
Yeah, I might have missed it.
So we're kind of in the middle of something here.
That's cool.
All right, SE. So the elevation in the center of the arm is 63 feet. But
Okay.
level drops away from horizontal. It drops away at a rate of 8 inches times distance in miles squared.
Okay.
So
Your arms.
63 feet elevation there in the center is going to be way below that. It's going to be a foot below that horizontal, that arm by the time you get to the end of it. So in order for the damn thing to be sitting on the ground, the elevation has to come up.
How so? I mean, I don't understand. Isn't your 8 inches per mile squared the other way? So how could your arms be going upwards, Blue? I mean, maybe it's me that's confused here.
Yeah, I think you're just. I wish I could draw a picture of this, but the
Yeah, please, that would help if you can do that.
I wish I could, but you've seen it. You've seen me draw it many times. I think. Just think about this. That elevation, that is that's like a level line. That's the curved line. Elevations are all curved. Okay.
So you're saying the arm is curved?
No, the arm's not curved. The arm is straight.
On a plane, like we established, right?
It's in a plane. It lies in a plane with the other arm, yes. But the elevation there at 63 feet at the center, that elevation, it would be dropping away from that plane in both directions. And pretty much equally because the two end elevations are about the same. So as you go a mile and a quarter down the arm either way, 63-foot elevation is down below the plane by 1 foot. To get back up to the elevation of the plane, you've got to add a foot to it.
So you got to go up one way and down the other way on the arm. I mean, that's
No, you're going up both ways.
going up both ways
The elevation has to come
From the
up
center.
on both ends.
from the center.
Yeah.
I just can't see it on a plane. You gotta. I don't know. Maybe I'm the one not seeing this, but to me, It just doesn't make any sense at all. And on the other side, you have a 3-foot drop. Explain the other side.
Actually a 4-foot drop on the other side.
A 4-foot drop
Yeah.
on the straightest thing supposedly in the universe. Isn't that how Danik put it?
It's still straight, SE.
Still straight, but it has a drop.
There's a 4-foot change in elevation, but this is because of the point that they picked for that plane that the two arms lie in to be tangent to the ellipsoid. The point of tangency is actually down toward the bottom of that picture and about midway of the upper arm. That's where the plane is actually tangent to the ellipsoid.
Hold on, you said the tangent was on the other arm.
No, see, I was doing that just to help you visualize what goes on.
So now where did you place the tangent now?
The point of tangency for the tangent plane that the two arms lie in is down toward the bottom center of that picture.
The bottom center of that, where the numbers are?
Down below that.
Down below that is the point of tangency.
For the tangent plane that the arms are in, yes.
Okay, well, so it would be like a triangle. You would draw another line and close the triangle type deal, and your tangency would be there in the middle of that arm.
There's nothing there. It's the imaginary plane that the two arms lie in. That imaginary plane is tangent to a point down there toward the bottom.
Imaginary plane. Okay, I'm trying to envision this. Okay. So you got a 3-foot drop from one end to the other, but yet it's still in the center of the arm, of the right arm. It's still lower, and you still have elevation on either ends again.
Still have elevation on either end. Of course you do.
Okay, wow. This is something.
Okay, but what you then have to do, if you really want to see it, is you have to plot all of the elevations of both the arms. You got to plot each of the elevations, and then you see the curve.
You have to plot the elevation. You mean visually? How high?
You have to take the elevation data from the engineering drawings, from the as-builds, and plot that. Plot those elevations on a graph, and you'll see the curvature.
Okay, so you're saying if we go down there and take readings and A, B, C, and some points in between, we should see different elevations along the arm.
You will.
Okay.
Blake,
And the
can you show me
3-foot
something
drop?
besides the as-built? Is it got to be the as-built? Like that's after the shit was built. Show me some plans with them numbers on them, please.
Them plans with them numbers on them are in that drawing package, in the as-built. You can go back to Rev A.
Also use LiDAR
The
data.
as-built are meaningless, bro.
Huh?
You can also use LiDAR data to show that it's the elevation profile is curved.
Yeah.
Okay, let me ask another question, if I may, to Blue. So Blue, we have basically a triangle here, a plane, and we have a 3-foot drop of one of the arms.
4 foot.
Sorry, a 4-foot drop on one of the arms.
It's just a 4-foot elevation change.
4-foot elevation change on one of the arms on the plane, which is lower in the middle, higher on either end. And on the other arm, we don't have this 3-foot drop.
No, wait.
Which is also on the same plane.
Wait. Back up.
Okay.
When you started out talking, I thought you were talking about the arm on the right, the more vertical one. You're talking now about the arm on the left to start with, and there is no 3-foot change in elevation, SE.
No, you were right. I was talking about the one on the right. And then I switched to the one on the left.
Okay. The one on the right starts at 64 feet and drops down to 60 feet.
Okay.
That's not 3 feet, that's 4 feet.
Okay, 4 feet. Right. So one of the arms has a 4-foot drop.
Okay.
This is now on a plane, of course. And the one on the left doesn't have this 3-foot drop, which is also on the same plane, but it has a lower point in the center of that arm.
Yep.
And also a foot elevation on the other, on either point.
Yep.
Wow. And all this is on a plane.
Huh?
Okay. Wow.
Say it again. You said all this is on a what?
On a plane. This is, like we said,
On
this
a
whole
plane?
structure sits on a plane.
There isn't it. The two arms lie in an imaginary tangent plane. Yes.
An imaginary tangent plane?
There is no physical plane. You realize that, right?
Right. But I mean, we are talking about the straightest, levelest
Yeah.
thing
You
that
realize
was ever built, right?
We're wondering why they even come up with the word plane, Blue. Like we can't have a vertical plane, we can't have a horizontal plane.
Well, you
So
can have
why even invent the word plane if we can't have it in real life? If it's just imaginary.
Well, I find it pretty handy, actually.
To imagine.
Or something.
I mean, it is you do have a plane. You can have a plane not on a globe, but above it or below it or whatever, right?
Not a physical one, but you can
Well,
have
there
the
are no
surface.
physical.
Okay, that's all I'm saying.
Yeah.
It's not a physical plane. There's nothing
There are no
physical
physical.
there.
Oh my
Yeah,
God.
there's no a plane's 2D. There's no 2D physical
Right.
things. Yeah.
Right. That's all I'm pointing out to SE. It's not a physical thing. The two arms lie in a tangent plane. That's an imaginary plane, obviously. They're all, every plane's imaginary. So maybe I'm being redundant. I don't know.
Just like the tangent in the imaginary bottom there. Imaginary
Right.
plane, you said.
Right. You can't have a vertical plane in real life, can you, Blue? I mean, not talking about the redundancy of the imaginary aspect of it. Just in real life, we can't have a plane that's vertical, right? Only a line, right?
Vertical plane sort of doesn't make sense to me, but
Right. And you can't have a
No, that was right.
horizontal
That was
plane.
right, Brian.
Thanks, man. Thanks.
I'll say yes, you can have a vertical plane the same way you can have a horizontal plane.
Oh, there you go.
Yeah. The altitude, like in the Altaz coordinate system, is the angle on the vertical plane.
All right. Debate Blue on it because Blue says it's. What'd you say about a vertical plane, Blue?
I said it sort of doesn't make sense to me in one way.
Don't make sense, Ruif. Your shit don't make
Oh, I
sense,
know.
bro.
I know what Ruhif's saying. Yeah, I know what he's saying.
So spin that
So it does make
vertical
sense.
plane on the azimuth until it lines up with your star or whatever, and then the angle on that vertical plane is your altitude.
Right.
Doesn't make sense, Ruth.
Okay, I think it does. I think
Does it-
Blue understands what I'm saying as well.
According to Blue, not me. According to Blue.
Well, maybe it
Yeah,
makes
I
sense.
know
Then.
you
Does that
guys
make sense?
love. I know you guys love to pit globers against each other. Does
That's
Blue
my favorite
understand
part.
what I mean? Yeah,
I
I know what
understand.
he's doing. I'm
I
aware.
understand perfectly what Ruhif said.
Yeah.
I was reacting to something Brian said, that you can't have a vertical plane.
So we can have a vertical plane.
Yeah.
Okay.
Good. So we have
That's like
some-
life.